All right, here we go. We've got question number 8 on our college algebra homework number 6 in MyLab Math, and it wants us to graph the exponential function f of x equals e to the x plus 2. I've got that copied down up here. Let's examine what we've got here. All right, so the first thing you need to notice is that this is an exponential function because you have a variable in the exponent position. You also need to know what E is. Okay, so E, it's not only the base, E is actually a number. Okay, so everybody knows what pi is. If somebody says, "What's pi?" Well, it's 3.14. But it's not just that, it's 3.141592, blah, 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 more stuff forever. Okay, so E is an irrational number. It goes on forever and never repeats. E is similar to pi, okay? E is also irrational. It's a non-repeating, non-terminating decimal number, and E is 2.71828, blah, 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 more stuff, okay? So just understand that E is like pi in that it's an irrational number. E is a symbol that represents a number, okay? So what am I trying to say? E is not a variable. E is a constant. It's a number. And so now that we know that, we can actually go and find what they want us to find. They want us to find the correct graph. So the way that we're going to get a graph of this function is we're going to make a table and we're going to pick some x's to generate some ordered pairs. Now notice that the x is all by itself in the exponent position. The exponent is just plain old x. So some numbers that might be nice to start with might be -1, 0, and 1. And then we're going to plug those in and see what we get. So we need to calculate e to the -1 plus 2. And the best way to do that is with our handy dandy calculator, okay? So on our scientific calculator here, we can see that there is an e to the, it's in yellow, so that means we have to hit shift and LN to get the e to the. It's e to the -1, move down, plus 2, and that number rounded, let's round it to one decimal place, is about 2.4. 2.4 approximately. And then we're going to do that 2 more times. E to the 0 plus 2 and e to the 1 plus 2 and see what we get. All right, so the next one is easy. Anything to the 0 power is 1. 1 plus 2 is 3. E to the 1 is 2.7 approximately. 2.7 plus 2 is 4.7. And if, okay, I can tell you don't believe me. Let's use the calculator and prove it. E to the 0 plus 2. There you go, 3. And e to the 1 plus 2. 4.7 approximately. All right, so there we've got 3 good points. Now let's see if we can generate a graph from those 3 points, okay? So let's make us a graph down here. Let's see, -1 is at 2.4. 1, 2, 3. -1 is at 2.4, somewhere about there. 0 is at 3, and 1 is at 4.7. 4.7 is almost up at 5. And do you see we got a curve going on? It looks like it's curving up to the sky to the right. But what is this graph doing back to the left? Well, I've got some news for you. Every exponential function has a horizontal asymptote. And the horizontal asymptote is found at the constant, okay? So this graph is going to have a horizontal asymptote of y equals 2. So if we come down here to our graph at y equals 2, we've got an asymptote that this graph is going to approach but never touch and definitely never go below. And so here's our graph. Let's go to Desmos and prove that. F of x equals e to the x plus 2. And if we zoom in, you can see that there's our y-intercept, 0 and 3, and that verifies this ordered pair that we got here. And if I put the asymptote in there, y equals 2, look at that. You can see the graph getting closer and closer and closer, but never touching. And so that verifies our horizontal asymptote. Now, which one of these graphs is that? Well, that looks a lot like D. Can I pull that out and make sure? Let's see, this goes up to 4. 1, 2, 3, and an asymptote at 2. Yeah, so I feel good about D. Bam! So there's that problem. Correct. If you have any questions or comments, feel free to put them in the comment section below, or you can text me. And thanks for watching.